Good morning, everyone. Thank you so much for joining us for this week's Virtual Converter College. I'm Jessica Legleiter, the Converter Markets Training Manager, and with us today and this week are our friends with our Electronics Materials Solutions Division, what we call EMSD, and also our partners with Universal Laser Systems. I'll let them introduce themselves here in a minute, but just to cover a couple of housekeeping related items. We do have a rather broad audience today, so we would invite participation from the audience through the chat functionality of Zoom, rather than the hand raising function. That one's really tough for us to do in real time with the number of attendees we have on the line today. So we would invite you to ask questions, ask us to elaborate on topics using that chat function. You do have an option with a drop down to address just the panelists, which is there's 5 or 6 of us from the 3M team, as well as the Universal Laser team doing the presentation. If your question is sensitive in nature or specific to an application you want to keep more confidential, certainly you can ask your questions directly to the panelist group. However, if you can ask a broader question or want to elaborate on something that we can all learn from as a group, please feel free to toggle that to engage everyone. So all of the attendees will be able to see your questions. That way we can all learn from one another and continue to refine our skills and learn new things from the content today. I'm going to turn it over to Mike with Universal Laser Systems to kick us off, and we'll be keeping an eye on the chat and trying to answer those questions as much as we can in real time. Thank you again for making time to spend with 3M and Universal Laser Systems, and I'll turn it to Mike.
Great. Hey, thanks, Jessica, and thanks to Paige and Joseph for giving us the opportunity today to walk you through what we hope is educational, but also enlightening in terms of how easy and simple it is to use laser technology to process and convert many of the high performance materials that 3M offers. So I'm going to be your speaker today, Mike Flannery. I'm the Global Vice President of Sales and Business Development for Universal Laser Systems. And online in the chat room and also to answer questions is Ian Ferguson. Ian manages our materials science R&D group. His team of application engineers has years of knowledge and experience in laser processing. And we use that not only to support customers in developing proof of concepts, but also in working collaboratively with 3M and other companies to develop optimal process settings for new and interesting materials. Specifically, we're going to spend today talking about the go-to materials from the 3M Electronics Solutions Division. So today what we're going to do is talk about ourselves briefly, just to introduce our company, talk about a transformation that's been taking place for the last decade or 2 decades in materials science and how that's impacting the converting industry. We'll talk about challenges many of our customers are communicating to us about problems they're having or issues with processing high performance materials. And then we'll get to the meat of the discussion, which is the ease and accuracy of processing several 3M high performance electronics materials with our flagship product, the Ultra X6000. In support of today's webinar and overall education for the converter audience, we've created a resource page on our website. You see that here. On the resource page is a set of reports that document the processing and intricacies of several 3M materials, as well as videos and other information we're going to show today. All right, so let's get started. Just quickly, our company was founded in 1988. We have multiple office and manufacturing facilities in Scottsdale, Arizona. We design, engineer, and manufacture CO2 laser systems and the CO2 laser sources themselves, and have been manufacturing directly for the last 30 years. Part of Ian's responsibility is our Advanced Materials Processing Center. This is where customers and material manufacturers will send us projects. Effectively, how do I cut or kiss cut certain materials to a specific degree of quality and accuracy? Ian's team develops the processes and optimizes that for their end users. Our company has 2 international offices, one in Vienna, Austria, and one in Yokohama, Japan. We have over 30 patents in the laser technology space and over 110 sales and service partners in 67 countries. So we've been around a while and we've done a lot of things, and we'll talk about a few customer stories today relative to the converting world. So what is it we do? Well, we design and manufacture what we call laser processing tools or systems that enable customers to easily produce very accurate, high quality results. Our latest set of products provides the ability to precisely control critical laser processing parameters. We're going to talk in detail about what these parameters are and why they're so important in processing high performance materials. So Paige and Joseph, if you want, why don't you explain a little bit about why we're here today?
Yeah, definitely. This is Paige Wera. I am the activation marketer for these portfolios. As many of you know, we implemented a go-to material list. We've created new collateral. We offered virtual trainings. You see Joe there in the corner too. He's been helping me with that. We thought, how can we continue to build converters' confidence working with some of these intelligent tapes? We came across this opportunity to work with ULS, help build your confidence working with some of these new products, new applications, and then also save you time and money, which of course we want to do. You're going to see some cool videos later on that'll show some of the outcomes. They're going to show a little bit of like our top go-to materials getting processed. We'll point a few things out. So stay tuned. It's going to be really fun.
It really is. So yeah, keep going, Mike.
Okay, good. So one of the things that we've worked with 3M on for the last several years actually is our intelligent materials database, and the importance and criticality of that within the converting market. So I think I'll talk a little bit about exactly what is an intelligent materials database. Well, it's a predefined repository of critical laser processing parameters for hundreds of materials. Parameters such as laser power, wavelengths, the type of air or gas used to process the material are all part of the database settings. Well, what this provides is a set of improved productivity. It allows the user or operator to focus on being productive, not developing settings for a laser system through trial and error. I'm sure many of the people on the webinar are familiar with basic laser technology. One of the biggest challenges is developing the right settings and then being able to replicate those settings from location to location. The materials database effectively eliminates the need to go through that trial and error. The other thing is, you'll see today the process we use to develop these settings, it really eliminates the overwhelming complexity of processing so many different materials. So I've talked a little bit about the type of parameters or variables involved in processing materials. It's not as simple as it looks. This involves a lot of material science, effectively what the material is, what its characteristics are, but also what type of laser wavelengths and power is available. What is the optical configuration required to process the material to the desired quality and accuracy level? How do you deliver the beam? How fast? And what is the air or exhaust flow required to optimize results? all of this goes into the calculations and the database settings. From an end user's experience, all of that complexity is hidden through a simple tree structure. So what I'm showing now are screenshots from our laser system manager or control software for the system that's processing all these materials. Effectively, you select a material or material category, in this case, 3M materials. As you can see, we have several different categories of 3M materials in our database. The next slide shows we've selected 3M laminating adhesive 300 LSE. This is one of the more common 3M materials. And if you notice in the upper left, it shows DB vector cut. So this effectively means this is the process setting for vector cutting 3M laminating adhesive. Other parameters on here, you'll notice it shows the type of laser that we're using. This is all within the database. This is identified based on what the system is configured to have. And then other parameters that we'll get into, including the percent of laser power used, the speed of beam delivery, pulses per inch or PPI, airflow rate, which is effectively the type of air assist or compressed air used at the point of laser processing. There are other parameters as well, which we won't get into, but become critically important when dimensional accuracy is required, such as curve compensation. So the materials database hides all this complexity from the end user. All they have to do is identify the specific material, and start the job.
Mike, I just can't believe how much work Ian had put in and his team had put in creating this content that's now in your database. You know, for the audience, you know, we've done a lot of road shows on our conductive portfolios of thermal and electrically conductive PSAs. And, you know, the composition of the different materials are different. They address different needs in the market for EMI shielding or thermal management. And as such, all this work is now done and behind the scenes to enable you to provide solutions for your customers more quickly. Thanks, Mike.
Yeah, and Joe, thanks for being such a great setup guy, because we're going to actually walk through the process that Ian and his team goes through to identify all those specific differences in materials and optimize the process settings for the end user. So we talked a little bit about a transformation that's been taking place, and really in the material science and material manufacturing world, over the last 15 to 20 years, there's been a significant change. Most notably, composites and multi-layer polymers and composites have been taking the place of metals or other substrates due to superior performance and quality. We already know today, because of, say, the electrical vehicle industry, metals are replaced with plastics and high-performance composites for weight reduction and different properties. I don't have to go into too much detail other than to say there's a science behind this. These properties are actually designed in the material through specialized engineering and chemistry. And really, nowhere is it more evident than in the electronics industry. With Moore's law, in terms of everything becoming faster and smaller, and the demands of more functional electronics, it's actually placed higher performance demands on all the materials used within the electronics industry. Everything from product packaging to the types of thermal and electrical conductors and insulators that we'll talk about in detail today, substrates and interconnects, flexible electronics and flexible cable technology, obviously display technology, and energy storage. A few years ago, one of the more interesting things that happened to me was on a trip to Asia. And I visited 4 different countries: Japan, Korea, Taiwan, and China. And in 3 of those countries, I was presented with the exact same material from the exact same OEM manufacturer. And the converter was actually asking me, can we process this material? It happened to be a substrate used on the display of a Samsung smartphone. So what was taking place was the smartphone industry was driving the demands for higher accuracy, more complicated material processing. Those demands were effectively 50 micron cut accuracy in the outline of the screen of a new Samsung smartphone. Today, that seems commonplace, but several years ago, that was very leading edge. And what it did is it actually presented an opportunity and challenge. The opportunity was process the material to meet the requirement. The challenge was the existing tools that the converters had could really not meet the specification for different reasons. Specific examples of these scientific advancements are really evident again in the electronics world. And this specific example will go to show how far things have evolved. For about 20 years, copper foil tape was used for wrapping cables and protecting against low frequencies. It was a little bit of a jack of all trades. Well, today, the tapes have to be conformable and easy to apply to flex circuit designs for shielding applications and shield higher frequencies like 3 gigahertz processors. 3M, for example, has developed an entire suite of tape products, whereas 10, 15 years ago, we had a one-size-fits-all type of scenario. The challenge this creates is each one of these materials, as Joseph was talking about earlier, has a different composition, a different set of materials or layers of materials to deliver the performance. So what are we hearing from our customers? Well, we hear a lot of what we call traditional benefits of laser processing. No material deformation, no material fracturing when using it for converting. There's no tools, there's no dies. You get clean, accurate cuts. You can cut complex geometries. A lot of this is common knowledge within the industry that uses laser technology today. What we're hearing about our customers and why our technology seems to have some unique advantages and benefits. The extreme accuracy and quality of output that we can produce. As Paige and Joseph talked about earlier, we'll show some videos of some extremely challenging part designs being processed on these high performance materials.
Yeah, and Mike, we pushed you guys to really come up with some examples of some die cuts that are pushing the envelope. And for the audience here, just sit tight, wait till we show you some of the complexity that we've got designed in.
Yeah, so as we talked about this over the last few weeks, I've never seen people get so excited about die cutting. I'm sure everyone else will be feeling the same way. And a couple other key things, and the last point here I'll bring up is because of some of the unique technology we offer, materials that were once thought unachievable in terms of processing with a laser are now possible. And this is something that has become kind of a revelation for some of our customers. We have visitors into our facility from time to time. And a couple of years ago, we had a visitor from Key Converter, and we walked them through the process that Ian's team goes through. And we showed a couple different materials that we can process. And one of those materials was PTFE, which was Teflon. And the immediate response was, I had no idea we can do this. We need to get this in our catalog right away. So what that did was basically enable a new type of product or a new line of business for that converter. Processing organics and polymers is a very complex process. Metal processing has been around for several decades with lasers, and it's a very well understood and studied science. Because of the continual advancement in polymer engineering, there's things that come into play that are not so obvious. The first is laser energy absorption characteristics. I know this sounds like a mouthful, but what this is effectively each material can absorb laser energy at a different level. Understanding what the ideal or optimal wavelength is for a given material is critical in achieving the best possible results. As we talked earlier, there are significantly more variables involved in processing these materials than meets the eye. Things like waveform with fiber lasers, or the type of air assist used, is it perpendicular or is it delivered at an angle to the material, can influence results. So what we strive to do is solve this multi-parameter challenge. And to do so, we've developed a methodology that we're going to walk through quickly to show how we develop the parameters in this intelligent database that provides all the benefits to the end users. At a high level, this methodology is pretty straightforward. We understand what the material is, basically what its optical characteristics are, and then we develop a set of experiments to isolate each variable and optimize based on the desired outcome, which in our case is best quality and best accuracy, which improves overall yield for the end customer. To understand the material characteristics, we look at the absorption characteristics, which is the laser energy or light absorption of that material, and then the physical dimensions of the material. We then go through this planning of experiments to isolate each one of these laser processing variables to identify what the proper setting is to achieve the optimal quality and accuracy. At a basic level, the optical properties that we focus on are absorption, transmission, and reflection. And for our purposes, absorption is the key attribute that we're trying to understand and measure. So absorption is effectively the proportion or percentage of the laser energy that's absorbed into the material. So what this will do is tell us which laser is the optimal laser wavelength for removing or cutting material. The higher the absorption level, the better the fit or the better the match of the laser. This chart represents an analytical measurement of each material, showing that from 1.06 micron, which is a fiber laser wavelength, to 10.6 CO2, where is the highest level of absorption? In our case, we offer all three of these laser wavelengths. As you can see, the 9.3 micron is the highest level of absorption. It's approximately 2 times better absorption than a 10.6 CO2. What this means is that the laser energy will be absorbed, or more work will be done with the 9.3 laser in comparison to the 10.6. As we talked earlier, we actually go through and develop sets of experiments across all of these variables: laser wavelength, duty cycle of the laser, pulse duration, pulse spacing, or PPI as it's referred to, optical configuration, etc., to determine the parameters that go into the database. To walk through the optimization objective is to minimize heat effects, minimize kerf, and produce the highest possible edge quality. In this matrix, what we're doing is we're looking at the comparison of laser duty cycle and percent speed of the laser for different laser wavelengths and power levels. As we produce results, we measure these with analytical instruments, typically microscopes, and identify what we call the ideal or optical sweet spot. We determine if there's any other influences using other wavelength combinations. And then we effectively mark that down in our database. To give you a real life example, the material that we showed earlier on the graph is a simple polyimide film. In this diagram, you can see on the right-hand side the impact of simply using a 9.3 wavelength versus a 10.6 wavelength laser. The 10.6 micron wavelength laser produces excessive heat effects on the edge of this material, referred to as charring, while the 9.3 provides a much cleaner edge and much less heat effects, effectively a superior result. The bottom of the screen shows the same image along with a three-dimensional analysis that we use with microscopic photography to show the edge of the material itself. On the 3M converter resource page, each of the reports will show this type of information. It will go through the edge quality, heat effects, and even show the three-dimensional analysis of each part. This is the kind of detail that Ian's team goes through to provide optimal results in database settings.
Mike, you talked about a 3M converter page, and what you were referring to is that new part of the ULS website that's focusing on these materials and these test reports, right?
Correct, absolutely. So all 10 of the go-to materials within the electronics division portfolio have these reports as well as videos of material processing.
Excellent.
So we go through the same type of scientific approach in identifying each one of these variable optimal parameters for the database settings. The tool that we use is our Ultra X 6000. And we're going to use this tool and show you processing videos of different materials in just a minute. What our customers have told us is simple. They have access now to the broadest range of materials that can be processed with this systems. Its accuracy and breadth of laser wavelengths and power available give them the ability to process materials that they haven't been able to process before. So one of the key technologies that we offer within the Ultra X 6000 is MultiWave hybrid technology. This technology was designed to provide the ability to combine multiple wavelengths into a single coaxial laser beam. I know that sounds like a lot, but what it does, it gives unlimited ability to process different materials, combining 9.3, 1.06, and 10.6 into a single coaxial beam that can be applied to any material. Each component of the laser, in terms of peak power, average power, power density, et cetera, can be controlled. So from an experimental perspective, we have unlimited possibilities. But the real pragmatic value is it gives customers the opportunity to process materials they couldn't process before.
Yep.
And we're actually going to use a 3M product as an example. So the 3M 5599 is one of the go-to materials in the set that we're going to talk through in detail. We went through. Go ahead.
The 3M 5519 is in our thermally conductive gap pad portfolio. This is one of the chemistries that provides the absolute highest thermal conductivity with a 5 watt per meter Kelvin performance. And through this process, they've identified that the MultiWave hybrid technology is optimal for this material.
Yeah, so, and Joseph, one of the things that you'll see in the video later is kind of the cleanliness and the quality of the cut. And the experiment and the scientific approach that we use, I'm going to quickly show some of the results. We went through the analysis of the material, and the PET liners effectively absorb 9.3 wavelength the best. So we started by using 9.3 as a way to process the material. As you can see from this diagram, the results were less than optimal. We had excessive heat effects in fracturing and effectively poor quality in cut. So it's really not a good answer. The middle layer, this filled silicon ceramic elastomer, absorbs the 1.06 wavelength quite well, but it's actually transmissive, or it goes through the PET layer. By applying 1.06 only to the material, we're able to remove the middle layer, the filled silicon layer, and through the thermal effects, the top layer of PET was effectively burned off. But the bottom layer remained. This is a great kiss cut, but it's not an ideal through cut. So by combining 9.03 and 1.06 together in MultiWave configuration, you can see that we were able to cleanly cut all 3 layers at an acceptable level. So by using traditional laser technology, we could not produce an acceptable part. And now by using MultiWave hybrid, we can accomplish the goal. So for 3M and Universal Laser Systems, we looked at this as a significant win and a good reason to help move this material forward in the market. Okay, so now we're going to talk and show some detail of processing several 3M go-to products. The first one is 9707. And as you can see from this chart, 9707 is a multi-layer material. The top and bottom are PET layers, and the middle layer is an acrylate adhesive with, I believe, silver conductive materials and particles.
You got it.
So we used a single 30 watt 9.3 laser to process this material based on the material characteristics. And you can see the aggressive geometry of this part in terms of what we used as the design drawing. So I'm going to flip to a video. And what you'll see in the video is our system has an autofocus capability, which effectively ensures that the laser is at the proper focal length to process the material, and then the job will start.
This is on the website too. It's awesome.
Yep, and like Mike was saying, this is filled with silver particles, so that makes it ultra conformable, which is great for microelectronics, but it can also make it a little bit harder to process if you don't have the right tools. So watch as the laser quickly processes these kind of tiny squares. It'll do some circles, and then when it starts outlining, it's amazing how fast this goes on the outline. And it's also going to be doing some really curved, smooth edges. With silver particles, you got to be careful that there's no degradation to the material. It's not pulling on it when it's cut. And we don't have that problem with ULS's lasers. So look at this, look how easy that comes off. And that's because of how clean and precise the cut was. And this is where Joe and I kind of geek out, is where he picks it up with the tweezers, and you can see that it just easily comes right out, showing how clean and precise it really is, which is not easy with this material.
We kind of pushed Ian at the beginning to come up with some geometries that were complex, but as you've learned in our conductive road shows, 9707 EMI shielding in a conductive PSA, think of that as a gasket used for EMI shielding of some sort of section within the final assembly. Those 4 round holes at the corner could be some sort of mechanical fasteners, but that gasket then creates the shield. Good shape there, Ian.
Mm-hmm.
Okay, so our next material is 3M electrically conductive double-sided tape 9711S. And this is unique because of the woven fabric as the middle layer. So we have a similar PET liner on the top and bottom. And then the middle layer is a nickel copper coated conductive woven fabric. Through the analysis, we also determined that a 30-watt 9.3 laser would be ideal for cutting this material. And in terms of challenge geometries, I think this is about as aggressive as we could get in processing this material. So again, we'll show the video of the material being processed.
Yeah, this woven fabric carrier, think of it as like a tight fabric. When I say woven, some converters think, great, this is going to be difficult to process, get clean edges, but you're going to see in the video that that's not a problem with this equipment. And also think about how small this design is. It's creating a very small and intricate design. So we're going to be looking for smooth edges. We need to have minimal heat affected zones. And also look how fast it's going with how small this is. So you'll see a little bit more of that when they pull the excess piece off.
This shape is really interesting in that it has a gasket again, but it has little small individual cavities. And you'll see them here when he picks it up. But I've had applications where someone's looking for a high adhesion conductive PSA. This 9711S is one of our better, categorizes our best conductive PSA for adhesion. But the end user I work with wanted to have an EMI shield within smaller cavities of the overall assembly. So those small little internal cuts with those thin rails that you saw in that die cut, that's exactly what we talked about. Thanks.
Yeah, so we're really excited about the opportunity this presents to all of our converter customers. So the third material is 3M thermally conductive adhesive transfer tape 8810. This could have been 8805, 8815, or 8820. As you can see, this is a similar layered material with the top and bottom PET release liner and a middle acrylate adhesive layer with ceramic particles, not silver and not woven copper. This also required a 30-watt 9.3 wavelength laser.
Yeah, this is the tape that Joe and I used to show conformability in that golf ball demo. It's the first one. And because it has some viscoelastic properties, it makes it a great solution when you're going to be bonding moving parts that are kind of shaking, vibrating. And it can be difficult to do that without, kind of deforming the material when it can be a little bit more stretchy. So you'll see here that there's no pulling at the tape when it's processed. There's no visible deformation to it. It's a clean cut. The tape's physical properties are the same, and that's what's important. You don't want to degrade the material.
And then our last example is the 3M thermally conductive silicone interface pad 5519. If you remember, we used this to demonstrate the capability and benefit of our MultiWave hybrid technology.
Yep.
What's interesting about this is it also has the same PET top and bottom liners, but the middle layer is a filled silicone elastomer. And the CO2 wavelength is not absorbed at all within this layer. So by combining a high power CO2 along with a 50-watt fiber laser, we're able to cleanly cut through this material and provide the same kind of quality edge and minimal heat effects as the other examples.
Yeah, the 8810 thermally conductive tape is one of our go-to materials here in EMSD. And, but this is a silicone-based thermal gap pad. And as such, as Mike just said, you had to figure out the best way, an optimal way to process it. And it became that multi-wave technology. But speed's the same, edges clean, part looks good. And how many of these videos then you've characterized pretty much our go-to portfolio of thermally conductive and electrically conductive PSAs? So
yeah,
probably about how many out there now on the website?
So there's 10 out on the website altogether. We'll kind of summarize that at the end. Each one has a material processing report that identifies the key parameters used, as well as microscopic images of the parts. And each one has the same kind of video that walks through introduction to completion. So one of the obvious things here is, what about production? What we've done so far is showed videos of developing a beautiful sample, but we're all in the business of production. So you can easily go from concept or proof of concept to production on this system. By using the 9719 as an example, we created a 28 by 22 array of parts on the Ultra X6000 work surface. Each row of parts took 6 minutes and 56 seconds, or an average of 14.8 per part. There are performance tricks that you can use by sharing cut paths, et cetera, that we didn't go through, but you can effectively go from proof of concept and customer acceptance to production just by duplicating the design file within our software. As Joe alluded to earlier, for the 3M go-to products, we've processed 10 of the key transfer tapes and gap pads and other materials. We used 6 different combinations of laser wavelength and power levels to achieve the optimal quality. And all of that was done on the same system. So effectively, our message is you can have one tool and support the ability to process all of these high performance materials. So for takeaways, we really see there's 4. One is many of today's high performance materials are complex combinations of polymers, composites, and even metal foils. We know that today's traditional tools and methods for cleanly cutting and processing these materials have some challenges. Laser processing requires using the optimal laser wavelength based upon the characteristics of these materials. Doing so has a profound impact on output quality. And our Ultra X6000 has proven to easily and quickly convert these materials and thousands more. So just to summarize, for 3M converter customers, our resource page on our website has all of these details, including all the videos. And if you have any questions, regarding testing materials or developing a process for some of your existing materials, please contact us at this email address, or you can contact me directly, and we'll do our best to help you. So we're kind of at the end of today's webinar. Questions?
Yeah, one of the questions, Mike, that came up in conversation is, limitations on thicknesses of materials or even thin materials. And I just wanted to reiterate that in the testing and Ian and his team had done, the thickness of the materials range from all the way down to 2 mils, all the way up to about 80 mils. So in the go-to 3M conductive portfolio of products, the library is now updated with materials that are in that range.
Yeah, it's a good question, and one of the specific things that we get asked quite a bit is for very thin materials. You mentioned things like 2 mil thick. Do you have vacuum table capability with the system to effectively hold the material flat during processing? And the answer is yes. That's an integral part of the Ultra X 6000. So great question. Anything else?
There was a question about higher scale production, and is there compatibility with the machine used today with higher quantities of parts?
So that's a really good question. The systems that we have today have a work area range up to 48 by 24. There is the ability to integrate automated material handling, such as roller feed or shuttle feed into the system. That's actually controlled by what we call an automation interface to interconnect into those material handling systems.
So it's possible. Yep.
It is possible. We do have customers in different parts of the world that have integrated third-party material handling into our systems. Yes.
And that third party for the integration systems. Yeah.
Correct.
Maybe reach out, Scott, reach out to Ian after the call, and he might be able to provide you some additional information in that area. Okay. Cool. Excellent. I didn't see any other questions coming up, but go back to the previous slide. If anybody wants to take a screenshot of that right there, get a hold of Mike and Ian, and they can help you out in additional questions and comments. I kind of wanted to wrap this up and just say, something like this is what I wanted to say. 3M, we're known as this innovation company, but truly in the converter markets world, the part of the innovation to drive these product solutions to our mutual customers is from the converter. The converter drives innovation too. And you've got different tools at your disposal that you have today or have learned about today that help us deliver solutions to our mutual customers. So I wanted to just, on behalf of Paige and myself and the rest of the EMSD team, thank Universal Laser, for taking the time and it started with a phone call to reach to the point where we are today. The work that was done is going to help enable to deliver new solutions in new ways, to your customers. Keep it simple, save time, and save money. Mike, do you have any closing comments too?
Joe, thanks again for the opportunity, and I do hope that we've shown a kind of a low risk, high reward way to get yourself into some of these higher performance, higher value materials. We know at times some things seem unachievable, and what our goal is to effectively show you how easy it is to process these materials at the quality your customers expect.
Exactly. Yeah. Excellent. Well, hey, on behalf of Converter Markets and 3M and all of our customers that we work together with, thank you so much for our time spent together today. And if you have any other comments, please reach out and we'll be happy to help.